Ladies and gentlemen, hello and welcome, coming to you once again, not quite live, from One Take Studios, where today's topic is writing functions. Functions, quite frankly, is a gigundous topic, and so we are only talking about some of the basics today. Alright, so we are introducing some basic ideas behind functions. We will by no means talk about everything that has to do with functions. So for starters today, what I want to talk about is actually functions that are based on patterns. Oftentimes we see sets of numbers and we're like, what is the relationship between these numbers, and can I put that into a function? Not all functions have patterns, but some do, so we're going to look at a couple of those. Right here we've got a set of ordered pairs, so these are my x's, these are my y's, so -1, 2, 0, 3, 1, 4, and 2, 5. Based on this, I'd like to see if there's some sort of pattern that I can put together so that I can figure out how to write the function that's relating these two elements. This is a good question to ask yourself. What can I do to my x value that's going to turn it into my y value? What can I do to a -1 that'll turn it into a 2? What can I do to a 0 that'll turn it into a 3? The goal is to be able to answer this question and have this be the same answer for every single pair. So we're just working with the basics, adding, subtracting, multiplying, and dividing. So think about those four. If I have a -1 and I'm going to have a 2, how could that possibly happen? Well, -1 is smaller, 2 is larger, so we're talking about the numbers increasing. That means I'm probably going to get rid of subtraction because that doesn't make sense, and division also makes things smaller, so that doesn't make sense. So I am probably at this point looking at an addition or a multiplication type of idea. So let's think addition for a second. What would it take to make a -1 turn into a 2 if I added? -1, well, 2 is 3 higher than -1, so maybe my relationship is to add a 3. If that's truly my relationship, that's going to have to be the same across the rest of my ordered pairs. -1 plus 3 is 2. Can I say the same thing here? If I do 0 plus 3, will I get 3? Absolutely, yes. There we go. What about 1 plus 3? Will 1 plus 3 make 4? Yes. Hey, this is turning out pretty well. And then 2 to 5. If I do 2 plus 3, will that equal 5? Absolutely, yes, it will. So in each of these cases, I'm taking my x value and doing something, the same thing, to create the y values that go with it. So this equation might look something like this. I can find my y values when I take my x values and I add 3. That's it. That's the function that I would write to describe this relationship right here. I find my y values when I take my x values and I add 3 to them. So that, ta-da, is my function. What else might, let's do one more of these just to be on the safe side here. What if I've got 1 -5, 2 -10, 3 -15, and 4 -20? Different format from here. That's okay. Functions can be written as tables, they can be written as ordered pairs, they can be written as equations, they can be written as all kinds of things, graphs. So I want to keep the same question in mind though here. What can I do to my x to make it turn into a y? Well, if I've got a 1 and it's going to turn into a -5, this time it's going down. From 1 to -5, it's decreasing in value. So that means either I'm looking at something that's subtraction, because that would make things smaller, or maybe I'm looking at division, possibly, that makes things smaller. Or, think about this carefully too. All of my x's are positive, 1, 2, 3, 4. All of my y's are negative, -5, -10, -15, -20. That's worth thinking about as well. Let's ponder subtraction for a moment. What can I do to a 1 to make a -5? What if I were to subtract 6? 1 minus 6 equals -5. That's true, isn't it? Yeah, okay, I like that. So does that work for my next pair? We're looking for the same relationship, the same pattern across the board. Can I do 2 minus 6 and get -10? Well, actually I can't, because 2 minus 6 is -4, so this isn't going to work. Subtracting 6 is not going to be my function. It's not the rule for my function this time. Notice what I did. I tried something. It was wrong, so I erased it. This takes some trial and error sometimes. You might not see it right away. That's okay. Keep trying. So how else might I get here? Well, if I do 1 divided by something to get -5, that doesn't really look like a division thing. But what if I multiplied by a negative? because I did say that all of my x's are positive, all of my y's are negative, so maybe I multiplied by a negative number, because that would change positives to negatives. So 1 times what is negative 5? Well, that would be times negative 5. Does that work? 1 times negative 5 is negative 5. Yes, let's see if that continues. Can I do 2 times negative 5 and get negative 10? Absolutely, absolutely I can do that. All right, so this is turning out to be pretty good here. Times negative 5. I'm putting my negative 5 in parentheses just to make it look so it's not subtraction, because subtraction we tried and subtraction didn't work. 3 times negative 5 is negative 15. You better believe it. And hopefully we can finish this off then. So can we do 4 times negative 5 is 20? Yes, absolutely yes. So that means I can write my function for this one as well. I can find my y values by taking my x values and multiplying them by negative 5. Do I usually write things like that? Maybe not quite. So maybe I write it like this instead. Y equals negative 5x. I'm taking all of my x values and multiplying them by negative 5, and when I do that I can find the y values that go with it. There's my function. Okay, so things to remember if you are looking for patterns and writing functions based on your patterns. You need to think about probably the basics for starters, so adding, subtracting, multiplying, dividing. They can obviously get more complicated than that, but if you're just starting out, probably those 4 operations are good things to think about. And you need to be patient with these things. Keep trying. If something doesn't work the first time, that's okay. Keep trying, play with it, see what happens. You'll get it eventually, I promise you. All right, so next up, I want to talk about something that is very specific to, well, I guess graphing and functions. All right, so those two things together. So still talking about functions, but I'm going to sort of walk away from this idea of patterns here and focus on something different. So this time I want to talk about independent variables and dependent variables. Independent variables are the x values. I guess I can put an S there for variables. What does that mean? This is a little bit hard to describe, and a lot of people actually use the wrong word, so you want to be careful. I think of this kind of as being the driving force between the two variables. We know we have x and we're going to have y here in a second. Between x and y, x is the driving force. It is independent. It does what it wants to do. And then the dependent variable is the y. If this is my driving force, this is what happens as a result of that. Y is my outcome based on what has happened for x. So the y, the dependent, depends on the independent. This is very much like a conditional statement, like if and then. The kind of idea that if I clean my bedroom, then I can go outside and play. Well, okay, I might clean my bedroom. I might not. That's independent. Who knows what's going to happen there? But that is the driving force behind whether or not I get to go out and play. Because going out to play depends on whether or not I've cleaned my room. This is the x, this is the y. The biggest word that people use incorrectly, they will try to use the word cause and say that this is the thing that causes the dependent variable. And you want to be very careful because often the word cause is going to be inaccurate. So I like driving force or something of that nature. Or again, thinking if it's if and then. If this happens, then this happens. So I want to look at that just in terms of some words for a moment and being able to identify if I've got a couple of things, how do I figure out which one's independent, which one's dependent? So if I know, for example, that a small jar of honey costs $3 and a large jar of honey costs $5, well, can you identify the fact that there are two things here? What would those two things be? Well, what do these sentences kind of have in common here? We've got a small jar and a large jar. So that seems like that's important because we're talking about sizes. But then we also have money and money. So we've got what it costs here and what it costs here. So if I'm thinking about what are my two variables, I'm guessing the size of the jar, large versus small, and the costs are probably those two things. So the question then becomes, which one is independent and which one is dependent? Which one depends on the other? Does the size of the jar depend on the cost? Does the cost depend on the size of the jar? For most people, one of those sentences makes more sense than the other sentence. Again, another way to think of this is if and then. if it costs $3, then I have a small jar. It sort of makes sense, but it's more likely that I'm going to say if I have a small jar, then it's going to cost me $3. If I have a large jar, then it's going to cost me $5. So when I'm looking to set up what is independent and what is dependent, independent is going to be the size of the jar, because the cost of the honey is going to depend on what size jar I pick up off the shelf. If I pick up a small one, I'll have a smaller cost. If I pick up a large one, I will have a larger cost. So again, that usually makes more sense one way than the other, and that can be difficult for people to pick out. So again, practice is helpful. I'm going to go with one more because I think this one's a little bit more difficult to read. A plumber charges $80 per hour. That's it. That's all you get. Can you pick out that there are two things in here? What's in this? Well, we've got the plumber, we've got the cost, how much is charged, we've got hours. Out of those three things, can you guess which two of them are going to be independent and dependent, and which one of them is not part of our conversation right now? The plumber is going to show up or not show up, so I guess you can sort of think he's independent, but not really. Because, let's think about this. Can you put this as an if-then statement? If the plumber is there for 2 hours, then I will pay $160. If the plumber is there for 1 hour, then I will pay $80. The cost that I'm going to pay depends on how long the plumber's there. So if I'm, again, trying to put together what is independent and what is dependent, this cost element is present, and my hours are also part of this. So independent is hours, and then the cost depends on how many hours the plumber is going to be there. If you have time, time is almost always your independent. Not always, but almost always. So hours, days, months, years is almost always going to be independent. Okay, one more page I want to look at here, one more set of things here. And that's going to be, again, looking at some of the basics of functions. Again, I'm going to kind of mostly abandon what we've got here and get us another fresh start. And that is the idea of function notation. Function notation. How do I write something as a function? Well, we've seen a couple functions so far, but I haven't actually used official function notation with you yet today. And I want you to compare these two equations right here. They say kind of almost the same thing. You're probably more used to saying y equals x minus 2, okay? But this, believe it or not, says the same thing as y equals negative 2. They are both equations. They are both functions, but this one happens to be in function notation. So what are we implying? Ladies and gents, these two are essentially the same thing. This is the same thing as having a y. Now notice I keep saying this. I haven't pronounced it correctly yet. I haven't read it correctly. A lot of people will look at this and they will say, that looks like f times x. And you're right, it does look like f times x. But I'm going to tell you something right now. Arrow. This is not f times x. Okay, I promise you it is not f times x. So what is it? What is the correct way to read this? It is read as f of x. F of x. And really it's meant to show the independent-dependent relationship. This is my outcome, my y, and it depends on the x. So whatever the x has going on, that's going to be the driving force behind the outcome of my function. So again, this is function notation. It has f of x equals x minus 2. Both of these are functions, but this is considered to be a regular old equation, and this one is function notation. F of x is one piece. It is not two different components. That's one chunk right there. And it replaces the y. It means the same thing, essentially, as the y. A lot of people are sort of scared of that because it's like, ooh, I don't know what that means. Can I make it less scary maybe for you? I look at this and I see this as being a name tag. That's all it really is. It's a name tag. F of x says, hi, My name is Fred. Oops, that's an S. Why did I pick Fred? Because it's F. My name is Fred. And I use the variable X. That's what that really just says. Hi, my name is Fred, and I use the variable X. This is my name tag for my function. It's not part of my calculations. It just says, hey, I have a name. It's not always F. Sometimes it's G. Sometimes it's H. Those are the most common letters. Most people for functions use F, G, or H, but honestly, you could use any letter that you want. And you're just saying, hey, this is my name, and this is the variable that I use. So my name is Fred, and I use the variable X. Less scary that way, hopefully. All right, so let's look at one more thing then that's kind of tied into this, and this idea of evaluating functions. Hopefully you see the word value sticking out there a little bit. Evaluate means to find a value, so we can do that. And what I have here is a function f of x. So hi, my name is Fred. I use the letter x. And this is the rule for Fred's function. If I have x, I'm going to take 2 away. Notice I use the same function up here. I decided we're just going to use the same one again for a second. So notice his name is still Fred, still f. Well, this says f of 8. This says, okay, I want to use Fred, but what happens to Fred if I replace the x with an 8? Well, I'm just going to keep up the trend. Fred uses x. Well, what if Fred uses 8 instead of x? Equals sign, take out the x, replace it with an 8, and then still do the -2. So when we are evaluating functions, we are really putting a number in place of the variable. And simplifying. Notice I did not use the word solving. We're not trying to get x by itself here. The x is gone. I replaced it with a number. All I need to do is, what is 8 minus 2? 8 minus 2 is 6. There we go. That right there is f of 8. f of 8 is 6, which, by the way, means that 8 is independent and 6 is dependent, because the 6 depended on the fact that we put 8 into the function. Let's do one more. What about using Fred with -1? Again, f, same function, but I'm saying this time, instead of the x, what if I use a -1? Well, instead of the x, I'm going to put a -1, so it's -1, and then still -2. What is -1 minus 2? That is -3. And there we go. Now I have another pair. I put in a -1, I get out a -3. Independent is the -1, and the -3 is dependent upon the fact that we put a -1 into things. All right, I want to look at one more just because life. All right, notice I changed my letter here. This is Fred. This is Georgette. Okay. All it's saying is, hey, I'm a different function than the last one, which we can see. This was x minus 2. This is x squared plus 1. Ooh, x squared. We can do this. What happens to Georgette if I take out the x and I put a 4 in its place? Well, this was x squared. I'm going to replace the x with a 4, so it's going to be 4 squared plus 1 plus 1. 4 squared plus 1. Let's think about that. 4 squared is 16 plus 1, because squared just means 4 times 4. Any number times itself, that's squaring, equals 17. So, ladies and gents, g of 4 is 17. One more for the fun of it. What if I use a -2 with Georgette? That means I'm going to have -2. Notice I am writing it with parentheses. Why am I doing that? Ladies and gentlemen, when you've got the negative there and you're squaring things, you got to be really, really careful. This means that x is being squared. This means x times x. Well, that means when I put in -2, that means -2 times -2. If you put this one in the calculator the wrong way, you will get the wrong answer, because the calculator will do exactly what you tell it to do. And we want the calculator to square the negative and not just square the 2. So what is -2 times -2? That's going to be 4. Plus 1 is 5. So the value for evaluating g of -2 is 5. All right. So again, this is just an introduction to some of the basic things for functions so that you can sound like an intelligent human being, because you are an intelligent human being. This is going to take some more practice and kind of getting used to things, so practice. Enjoy.